one more time since we're recording now. If you have a TI-30XA, all right, or even a Casio or a whatever other calculator, does everybody in here have a Texas Instrument? I think everybody in here, I'm looking around, most of you got a TI, right? And looks like most of you have a TI-30XA, which is perfectly fine. I used that all through college. Actually, anyway, something like it all through college. And it's perfectly fine, but this is what you would do. You'd still write it out like this. But when you put it into your calculator, this is what you would do. You would hit 3 divided by 5 equals first. All right, so you do the number first, and then you hit the function. All right, on on the regular scientific calculators. If you have a graphing calculator, you do it exactly the way it's written. All right, so graphing calculator, you do it exactly the way it looks right here. Doesn't that look exactly the same as this? Yep. But on a TI-30XA, you would hit 3 over 5, make sure you hit equals, all right, and then it comes up with a 0.6. Then you hit second function, which is the yellow button, and then you hit sign. You don't have to hit it equals after that. Automatically, you'll get that 36.9 something. Everybody good with that? Okay. All right. Now watch. This is the cool thing. We'll go through this a little quicker this time. So angle A is 36.9 degrees. That's what this angle is right there, 36.9 degrees. What would this angle C be equal to if this is 36.9? How would I find, I should ask you that, how would I find angle C if I know what this angle is down here? Subtract it from, no, I don't have to take it from 180. Just take it from 90, right? Because this is already 180 minus 90, right? Remember, these two add up to 90. So all I got to do is 90 minus 36.1. And I'm not 0.1, I'm getting ahead of myself. 0.9. And then what's that? That's 53.1. 53.1. And that's what this angle right here would be. 53.1 degrees. Make sense? So now look at that. By using the trig function, we found this angle, and very easily we were able to find the other angle as well. But I want to do something. I want to show you this. See how I wrote all three of these? Right here, right here, and right here. Angle A should be the same thing with all of these, right? So let's try it again. Let's use the cosine this time. I'll keep it all in pink. Let's do the cosine of A. What's the cosine of A equal to? It's equal to 4 over 5. Plug that in your calculator and see what you get for A. So most of you guys have the TI-30, right? Lauren, you got the graphing, right? Anybody else have a graphing calculator? Okay, Jada, anybody else? All right. So with a graphing calculator, you would do it just like we did up here, okay? Except you're not using sine this time. What are you using? Cosine. And instead of putting 3 over 5, what are you putting in there? 4 over 5. All right, so try it. You should get the same exact angle, do you? Yep. So watch. Second function, cosine of 4 over 5, 4 divided by 5, and I get the same exact number. I mean, to the number, all the way to the end. It's the same exact thing, isn't it? It's no different at all. What about doing the tangent? Let's do the tangent. These little dots out of the way. It's bugging me. Let's do the tangent. So the tangent of A, what was that equal to? 3 over 4, right? So plug that in your calculator. See if you get the same answer. You should get the same exact answer without any fluctuation whatsoever. Do you get it? Yep. Put 3 over 4 equals, right? You get 0.75. Hit second function tangent, and bang. You'll get that same exact 36 point whatever, 9, blah, blah, blah. We good with that? All right. Now, what if we did the same thing with C? What if, now, we already figured out what C was, right? We already talked about that. But let's do the calculator work on it. Because if we figured out A was 36.9, we took it away from 90, and we got this to be 53.1. But let's say we didn't want to do it that way. Let's say we wanted to use the trig function. So we could do this. We could pick any of these three. It doesn't matter which one. Let's just pick the first one. All right. So what are we going to do to get C by itself? We're going to take the inverse sine of what? 4/5. So try that. Put that in your calculator, see what you get. Hit 4/5 equals, that's 0.8. Hit second function sine, and you should get something pretty close to 53.1. Do you? Yeah. Let's try it. So let's put it over here. So what do we get? We hit it's the inverse sine of 4/5, right? So second function sine of 4 divided by 5. And that gives you, yeah, look at that, 53.1, just like we said it was. Isn't that cool? So that's 53.1. We got it two different ways. And if you wanted to, we're not going to waste the time on this, but if you wanted to, you could do all the rest of these as well. You could hit second function cosine, right? Inverse cosine of 3/5, and you'll get the same number. You'll get that 53.1. Hit the second function tangent, right? The inverse tangent of 4/3, and you'll get the same exact number. Works out real nice. You okay with that? All right, let's do this triangle. I'm going to make it look a little different than what we've been making them look, but it's still going to be a right triangle. All right, so there's my right triangle. Let's put some numbers in this time. They tell you that this side is 13. This is x. Now, they don't tell you the other side, but they do tell you that that's 52 degrees. So this time they tell you the angle. They don't ask for the angle. So back here, when we did that angle stuff, that's when you do the inverse. You might want to jot that down somewhere, okay? You only use the inverse on your calculator when you're solving for the angle, okay? When you solve for the angle, okay, that's when you use the inverse. Okay? Everybody got it? Write it down somewhere. So when you solve for the angle, that's when you use the inverse. When you're actually solving for one of the missing sides, you're not going to use the inverse. Okay? You already know the angle. You're gonna do something different. All right? And let's call this y. Let's solve for both of these things. In fact, let's do this. Let's call this a, b, and c. Let's solve for everything that's missing. All right? So as far as the angles, what's missing as far as the angles are concerned? The angle A, right. Okay, and you can find angle A without doing any trig at all. What math would you do to solve for angle A? Yeah, 90 minus 52. And 90 minus 52 is what, 38? Is that right? So that was easy, wasn't it? 90 minus 52. Everybody see how I got that? I'll write it down so you see it. And that's 38. All right, so that's how you find that. Didn't have to do any trig. So if they give you one angle, one of the acute angles, you can always find the other one by taking away from 90. Okay, what about the sides, though? Can we do Pythagorean Theorem to solve for this? We always did Pythagorean Theorem with right triangles, didn't we? Can you do it with this one? You can use Pythagorean Theorem? Nah, because look, I got two missing sides. You can only use Pythagorean Theorem if I know two of the sides and I'm missing one. Okay, that's the only time you can use Pythagorean Theorem. So I'm going to have to use a trig function. Now, which trig function are we going to use? Well, it all depends which angle we want to take it from. All right, which angle do you want to use? Do you want to use the 52 or do you want to use the 38? Tell you what, let's just use the 52. That's one they gave to us to begin with. Let's just use that one, okay? So let's use the 52. And I'll tell you what, I'm going to even erase this just so it doesn't get confusing. All right, let's use the 52. And what do you want to solve for? Do you want to solve for x or y first? Doesn't make any difference. Let's solve for x, okay? Yeah, it doesn't make any difference. I just chose x because it's first. All right, so let's solve for x. Now, I'm using this angle right here. It's very important you know which angle you're using. Now, what I want to do is I want to label the sides that we're trying to find and label the side that we already know. So what is this side x right here to this 52? It's opposite. Very good. I'm just doing this for teaching purposes. If you need to do that, that's fine. But this is the opposite side. Now, I don't care about y because I already have one unknown. I'm not going to use this. This is the hypotenuse, isn't it? All right. But what's the other side that I do know? It's the 13. And what is this side to the angle 52 degrees? It's adjacent, isn't it? So I'm going to write that in there just so we remember. All right. Everybody with me? So now I'm using this 52 degrees. So now I've got opposite and I have adjacent. So which trig function? I'll write the mnemonic device again, down again. So it's SOHCAHTOA. Which one uses opposite and adjacent? It's the tangent. Good. So you look up here to see which ones. That's opposite and hypotenuse. That's adjacent and hypotenuse. But what do I have? I have opposite and adjacent. So this is the one that I'm going to use. Right with me? So I write down tangent. The tangent of what? What angle am I doing? am I taking right here? 52, right? So that's a little bit different than what we've done so far because we always took the tangent of some unknown angle. This time we know the angle. It's the tangent of 52. Equals what? Opposite over adjacent. Which one's opposite? X. And which one's adjacent? 13. Now this tangent of 52 right here, that's just a number. You can plug that in your calculator. You're not hitting, you're not hitting second function on this stuff. You're just hitting the tangent of 52. Now on your calculator, on the TI-30, how do you think you do this? You think you hit the tangent first on your calculator? No, what do you hit first? Hit 52 first and then do tangent. But I'm not going to do that right now. I want to get x by itself. Okay, I want to get x by itself. So how in the world do I get x by itself if it's being divided by 13? Multiply by 13, right. So you multiply this by 13 and you multiply this by 13. That cancels out. This is what you're putting into your calculator. Did that math make sense to you? So how do you do that on your calculator? I would do this first. See the tangent of 52? I would do that first. But you don't hit tangent, you hit 52, then tangent. Everybody do that. If you have a calculator in front of you, do that. Hit 52, then tangent. You get some decimal number, don't you? All right? Now, what do you do with that 13 to that number? Multiply it. So hit times 13, and then hit what? Equals, and you should get your answer. Let's try it on this calculator. A couple of you guys have this calculator, so let's try it on this one. On this calculator, you write it exactly the way it looks right here, which is kind of nice. It's 13 tangent 52. All right, that looks exactly like that, doesn't it? Did I have to hit second function? No, I didn't, because I'm not solving for an angle. I already know the angle. So I only hit the second function. I'm trying to solve for the angle. Does that make sense? All right, so we hit equals, and we get that. About 16.6. Is that what you got on your calculator? Yep, should be. So it's 16.6. What did we just find then? We found x. We found the length of that side right there. We didn't find an angle. Don't put degrees. All right, we found the length of that side. Make sense? Let's solve for y now. Let's do that in a different color. Change things up a little bit. Let's solve for y. Let's still use that 52 degrees right here. I have to go a little quicker because my time's starting to fade away. So let's use this 52 right here, and let's solve for y. Now, what is y? We already know that this is opposite and this is adjacent. What is y? It's the hypotenuse, isn't it? Okay. So now, let's pretend we didn't find x. Let's just go with the stuff that they gave us right at the beginning. So I'm using this angle right here. What side do I know? What side do I want to find? I know the adjacent, and I want to find hypotenuse, right? So I come over here to my trig functions. Which one am I going to use with adjacent and hypotenuse? Use the cosine. Do you understand how we know which sign or which trig function we're supposed to use? That's usually the main question kids ask me all the time is, I don't know which one to use. Well, use the one that works. All right? It sounds a little, a little quick there, but use the one that works. They give you the adjacent. You want to find the hypotenuse. That's what you're going to use. So adjacent hypotenuse is the cosine. So let's do this. The cosine of 52 is equal to adjacent, which is 13, over the hypotenuse, which is y. Again, I have to do this a little bit quick. Watch very carefully. Write this down. Okay, you can always watch it again on YouTube because I might not have time to repeat this. Y is on the bottom. All right? So I don't want it on the bottom. I want it on the top. So what I'm going to do is I'm going to multiply both sides by y. That's going to put it over here. But then I got to get rid of that cosine of 52. What do I do with that? I divide and put it where? On the bottom. So this was on the bottom. Where does it go on the other side? On top. This was on top. Where's it going to go on the other side? On the bottom. Basically, I just switch them up. I just switch places. So what's y going to equal then? 13 divided by the cosine of 52. And let's put that into a calculator, and that's about all the time we'll have for this. So it's 13 divided by the cosine of 52. Cosine of 52. Now on your calculator, what would you do? You'd hit 13 divided by what? 52 cosine, then hit the equals button, and you should get that answer. I hit plus. Oh man, I'm running out of time. Oh, there we go. What's going on here? Let's try it one more time. Do I have time? 13 divided by, I don't think I can do it. Cosine of 52 equals. Oh, I hit 55. Oh, well, I got to stop.